How do you analyze geospatial data to find urban change patterns? Imagine looking at a city over many years and seeing how it grows, shrinks, or transforms right before your eyes. That's what analyzing geospatial data helps us do. Geospatial data is information about locations and features on Earth's surface, gathered through satellites, drones, or sensors. It shows us where buildings, roads, parks, and water bodies are, and how they change over time. To find urban change patterns, the first step is collecting data. Satellites orbiting thousands of miles above Earth take images at different times. Drones can also capture detailed photos from lower altitudes. Geographic Information Systems, or GIS, are computer programs that store and organize these images and data layers. Using both remote sensing and GIS together allows us to compare images from different years side by side. Next, the data needs to be prepared. This means cleaning the images so they line up perfectly and removing any errors. If images are misaligned, it might look like there are changes when there really aren't. Once the data is ready, we classify the land. This involves using computer algorithms to sort pixels into categories like buildings, roads, water, or green spaces. Sometimes, machine learning models help automate this process, making it faster and more accurate. After classification, we compare the images from different years. This is called change detection. It shows us where land use has shifted, like farmland turning into housing developments or forests being cleared. We can measure how much new construction has appeared and where it is most concentrated. Mapping these changes helps us see patterns, such as which neighborhoods are expanding fastest or where green spaces are disappearing. To understand why these changes happen, we can add other data layers. For example, elevation maps or proximity to highways can explain why certain areas grow more quickly. Flat land near major roads often sees more development. Combining all this information helps us see the bigger picture of urban growth. Finally, we can use the patterns we find to make predictions. By analyzing past growth, models can forecast future changes. These predictions help city planners decide where to build new roads, parks, or housing. They can also identify areas that need conservation or special attention. Making this process interactive is a great way for students to learn. They can look at satellite images of their own city and spot changes over time. Using simple GIS tools, they can classify land types and create their own maps. Activities like mapping their neighborhood or predicting future growth make geography fun and real. In short, analyzing geospatial data to find urban change patterns involves collecting images, preparing and classifying the data, comparing changes over time, understanding the reasons behind those changes, and using the patterns to plan ahead. When students see how cities grow and change through these tools, geography becomes a hands-on adventure they can explore themselves.